Hi guys, this is Miss Austin and I'm going to be going over the law of cosines. This is something you can use to find the missing side and angle. I'm going to do this in two parts. We're going to do the sides first. The missing sides of any triangle. Um, it's a little bit inefficient to use for a right triangle because you could use your SOHCAHTOA. So this is actually most useful for non-right triangles. So we use law of cosines to find a side when we have SAS. So I think you might remember that from geometry. When we have two sides and the angle in between. Okay, now there's a lot of letters here, and so I just want to make sure everybody remembers little letters in geometry tell us that we're talking about the sides of a triangle, and then capital letters mean that we're talking about angles. And if you have angle A, then side A is across from it. Side B is across from angle B, and side C is across from angle C. Okay, so we just want to remember that. Now this formula, sometimes you'll see textbooks write it out three different ways depending on which side you're looking for. I think it's best to just think of it as sides and angles. So you'll notice, right? That's a side, that's a side, that's a side. There's those two sides again. And then this capital letter stands for an angle. So what this formula basically says, whatever side you're looking for, you have to know the other two sides, and there's those two sides again, and then you have to know the angle across from that. If I'm looking for little c, I have to know angle C. So that's the angle across. So I don't want you to get caught up in the letters. I want you to just think about what you're looking for. So let's just jump right into an example. So it says, example 1, find B. Well, where is B? B would be right here. Little b stands for side B across from angle B. So let's look at what we have here. We have a side, we have an angle, and we have a side. There's our SAS. So this is the side I'm looking for. There's the other two sides that I know, and there's that angle across from it. So if you look back up at the formula, it doesn't matter that I'm looking for side B. Even though the formula says C, don't worry about it. Whatever side you're looking for, you're just going to plug the other two sides into those slots, and you're going to put the angle across from the side you're looking for. So let's see if we can get everything put in the right location. Here we go. So B squared is equal to the other two sides. It does not matter if you put 6 first or 10 first. Addition is commutative. Minus 2 times, got to put those two sides again, times the cosine of the angle across from the side we're looking for. We're looking for B, so I need angle B. Okay? Again, it does not matter if you put the 6 first or the 10 in either of these spots. And then the great thing is this can get typed right into your calculator. If you want to practice with me, you want to make sure you're in degree mode. 6 squared plus 10 squared minus 2 times 6 times 10 times the cosine of 82. I'm going to kind of show it in steps here. You could do it all on your calculator without recording this middle step. So I got 119 point, I'm going to go to the thousandths place. Now notice that says B squared. I don't want to know what the side squared is. I want to know what B is. So now I'm going to take the square root of both sides. Do that on my calculator. And I'll round to the tenths place now. So that missing side is approximately 10.9. A common mistake with students is they'll leave this as the final answer. But try to think about what you're putting down. That doesn't make any sense, right? You couldn't have a triangle with sides 610 and 119.299. Okay, the sum of any two sides always has to be larger than the third, if you remember that from geometry. All right, let's try another one. This time it says find the missing side of triangle ABC if B equals 12, C equals 20, and A equals, or the measure of angle A equals 40. Okay, so we've got to draw the triangle. Now, it does not matter if you draw it to scale or where you put A, B, and C. Does not matter. I'm just going to go A, B, C. Now, once you decide where to put A, B, and C, it does matter where you put the given information. You need to put it in the correct location. So they gave me side B, which should be across from angle B. Well, I put my angle B here, so this means my 12 is right there. They're telling me side C is 20. That's going to be across from this 20. Yours might be in a different location. It doesn't matter as long as it's in the correct location, given where you put your A, B, and your C. And then it says, and the measure of angle A is 40. Now notice again, I just want to emphasize we have S, a side, the angle in between, and another side. S, A, S. This is when we use law of cosines. And it says find the missing side. Well, the only side that's missing is this little a. So a squared is equal to, don't get caught up in the letters. Whatever side you're looking for, it's the other two sides that go into the formula. So, and it does not matter if I put 20 or 12 first. 20 squared plus 12 squared minus 2 times 20 times 12 times the cosine of 40. All right, get to type that whole thing in my calculator. A squared equals 20 squared, 12 squared minus 2 times 20 times 12 times the cos of 40. I encourage you to at least try maybe while you're watching this to see if you can type it in and get it correctly once before you try the activities. Again, this is a squared. I don't want to know the side squared. I'd like to know what a is. So I take the square root of both sides using my calculator, about 13.3, the missing side. Seems reasonable. Okay. All right, third one. During a figure skating routine, Jackie and Peter skate apart with an angle of 15 degrees between them. Jackie skates for 5 minutes and Peter skates, 5 meters, and Peter skates for 7 meters. How far apart are they? All right, they don't give us any letters this time. So I'm imagining Jackie and Peter are like right here. Disclaimer, I will not be able to draw this to scale perfectly. So here's Jackie. She's going to skate for 5 meters. Here's Jackie now. And then here's Peter. And the best of my ability, I'm going to try to make a 15-degree angle here. And he skates for 7. There's Peter. It says, how far apart are they? Well, that's this distance. Well, we've made a triangle. And I do know that this is supposed to be 15 degrees. And notice, what do we have here? We have S, A, S. And they want me to find this distance right here, which I don't even have a letter this time. You could make up any letter you want. I'm going to call this X. So that would be little x. So here we go. X squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 15. Type that into our calculator. If your answers aren't coming out, one potential problem could be that you're not in the right mode of for your calculator. So make sure you are in degree mode. If you have a calculator and you don't know how to do that, usually if you Google the model number, you can find some information. All right, now this one's kind of tricky because you might think, oh, I'm done, but that's the side squared, right? So I need x, just the side. So I'm going to take the square root of that. And if you look at the drawing, it kind of makes sense. It looks like it should be less if you're drawing at a 15-degree angle. And I got about 2.53 meters. Okay. All right, so I hope this was helpful. The next part's going to be how to use law of cosines to find a missing angle.